technology program with you today in sort of an unconventional way, since I wasn't able to be here in person. You should have a packet containing this presentation, as well as additional information that will not be included in the presentation. I'm going to discuss quantitative and qualitative data that has been collected over this year. These data assess both our teacher training program as well as the instructional program for students. I will also talk about some of the things that we hope to implement next year. The teacher training program began with a needs assessment, which was a survey where the teachers indicated the technology skills and teaching abilities that they already had and the areas in which they needed more training. Following the needs assessment, trainings were offered based on the teachers' responses. In the fall, the trainings focused on developing specific skills with software such as the Microsoft Office package, whereas in the spring, teachers worked on integrating those skills with the content. The participants were able to choose 2 of the 4 skills training sessions based on their areas of need, but everyone attended the integration trainings and they worked cooperatively to develop lesson plans where they combined their classroom content with technology skills. Following the training sessions, teachers again filled out the needs assessment to indicate what skills they felt comfortable with and what skills they did not feel comfortable with. Areas in which there was a lot of growth were spreadsheets. On several of the spreadsheet questions, we saw a huge gain in teachers that felt comfortable with that skill, and then also in teaching the technology skills. This graph shows teacher responses to the questions, I can teach students to use a word processor, I can teach students to use a spreadsheet, and I can use technology to teach problem solving, which is a goal that we're working toward. The red bars indicate the number of teachers who strongly disagreed or disagreed that they were capable of doing that at the beginning of the survey. In the post-survey, the orange bars indicate the number of teachers who strongly disagreed or disagreed that they were capable of doing that. So there was quite a decrease in all 3 of those areas. The blue bars indicate the number of teachers or the percentage of teachers who strongly agreed or agreed that they could do the skills prior to the training sessions, while the green indicates the number of teachers who strongly agreed or agreed following the training session. So you'll see that we saw a lot more people saying that they could do the skills, whereas many fewer said that they could not do these skills. Areas in which we will continue to be offering training are digital presentations, web development, both of teacher web pages and using web development in classroom content, and using databases. Your packet contains the entire survey and the responses to all of the questions. This chart outlines the instructional program that was implemented this year. K through 5, students were taught to use software and technology vocabulary. 1st through 5th grade, students learned to use word processing at different levels depending on age level. Then 1st through 5th grade also, the internet was used to extend classroom content. Beginning at the 3rd grade level, the internet was used for research and students were taught about copyright and citing sources. 2nd through 5th graders learned to use spreadsheets including function keys. And 2nd through 5th grade students used PowerPoint. At the 2nd grade level, they made just 1 slide, whereas at the 3rd grade level, they made multi-slide presentations. And then at the 4th and 5th grade level, added in pictures, animation, and that sort of thing. 4th and 5th graders learned to use databases, and a formal assessment was conducted 3rd through 5th grade. The formal assessment consisted of a written exam and a performance assessment. The written exam was actually offered online, and it addressed word processing, spreadsheets, the internet, and databases. The performance assessment was a choice of 4 different technology projects that students could complete, and most of the students chose to do PowerPoint. Both of those assessments are included in your packet. Areas of strength in the instructional program were in PowerPoint and Word. Students were able to develop excellent PowerPoint presentations. They really enjoy using PowerPoint, and they're also able to add lots of bells and whistles to word processing documents. The 4th and 5th graders were able to extend the use of the different programs, whereas 3rd graders, when asked what would you use a spreadsheet for, generally stated things that we had used it for in class. And this isn't surprising given their developmental level. Another strength of the instructional program not indicated by the assessments are that the classroom teachers more and more brought in their own content to use with the software that we were teaching in the lab. So that was something that we're really growing in and continue to want to grow in. Areas where we weren't as strong were in the use of spreadsheets. Ironically, the second graders are very good with spreadsheets because they spent a little bit more time on that while we extended PowerPoint with the other grade levels. So that'll be something that we'll see grow over the next couple of years. Then also in the use of database. We'll need to teach more database skills next year. Finally, since all grade levels started at the same place this last year, you'll see from the graph that they all ended up in relatively the same place. Actually, the fourth graders performed the best on the written assessment, while the third and fifth graders performed about the same. So we'll start to see those grade levels spread out a little bit as we develop an aligned program throughout the grade levels.
One of the reasons I wanted to share this information in my absence was to provide an example of the direction that we need to take our technology program. Not only is this type of multimedia development required by the text, the state curriculum, but it also provides a way for students to solve real-world problems, convey information in a unique way, integrate the use of technology skills with various content areas, and it's fun. If, for instance, a math teacher teaches a unit on density, and in science the students are learning simple machines, students could develop a video showing the effects of moving the fulcrum and or changing the weights on either end of a seesaw. They could develop a presentation to go with their data, or use digital graphics to create a simulation of various changes to simple machines and the effect it has on their construction. Anytime students can have fun while pursuing and producing a product that they are proud of, there's a significant chance of retention. Needless to say, this will require more equipment, more training, and time to implement, but it's important to keep an idea of the long-term goals as well as our short-term goals. My email address is in the packet, so I hope that you'll email me with any questions, concerns, or suggestions.